One of the ways that geologists have inferred that the composition of the mantle is ultramafic is through the composition of lavas erupted on the surface of the Earth that are presumed to have been generated within the mantle. So, what you'll learn later on is that magma is generated inside the Earth, down deep inside the Earth. This is, say, the surface of the Earth here. Here's our proverbial, oops, there's our proverbial tree right here. And somewhere deep underground, magma is generated down here deep in the earth. That magma then rises up first as little driblets and eventually forming streams that sort of rises due to buoyancy. It may pause to collect in some kind of large pool underground called a magma chamber, as I've shown here. But eventually, at many locations, magma from that magma chamber then subsequently rises, forces its way to the surface, and then erupts on the surface through some kind of volcano and pours out on the ground as a lava flow that we can collect and pick up and analyze. And the point is that many of these lava flows are mafic in composition. They're mafic in composition. Almost all of the lava flows that have poured out onto the oceanic crust are mafic in composition, but mafic lavas also occur very commonly on the continents. Now, to be truth be told, the continents also includes lots of other compositions of lava. So it contains lavas ranging from mafic through intermediate all the way to felsic, but many of the lavas that occur on the continents are also mafic. So what's the big deal then if the lavas on the continents are mafic in composition? Well, later on you're going to learn how melting occurs, and it's quite a bit different probably than many processes that you kind of imagine happening on the surface of the earth. So rocks melt in a kind of funny way. Rocks, if this is a rock, a solid rock here, it turns out that we can show that rocks almost never, I mean virtually never, melt entirely. So the process of melting instead produces some small fraction of melt initially in the pores of the rock. So maybe 10 or 5 or maybe up to 25 or even 30% of the rock will melt, producing little blebs of magma in the pores of the rock. And then under pressure, under the great pressures that exist underground, this magma is squeezed out of the rock, and it sort of initially occurs in little driblets that just sort of coalesce to form larger streams, and eventually a large stream of magma that's been squeezed out of this rock will collect, rise to the surface. It might pause in a magma chamber, but eventually that's the material, that's the magma that gets erupted eventually as lava up on the surface. So the point is that this process of melting is always partial melting. We never melt the rock entirely. We only melt a portion of it, typically less than 30% or so. Now, compositionally, what happens is really interesting. What always happens is that the initial, when melting proceeds, the initial components, the chemical components of the rock that are initially melted tend to be the more felsic components, the components rich in silicon and sodium and potassium, and not rich in the mafic components, iron and magnesium. And as a result, there's sort of a rule of thumb you can write down that describes the composition of the partial melt compared to the composition of the rock. So remember that we could describe rocks, right, as ranging in composition from ultramafic through mafic and finally intermediate and felsic, right? Intermediate, I'm going to abbreviate that, and felsic. Those are the compositional categories of rocks. So the rule of thumb that's very that holds for partial melting is that when partial melting occurs, the magma has a composition that's one step more felsic than the rock. So if the rock composition is mafic, then the magma's composition, when the mafic rock partially melts, it will generate a magma that is of intermediate composition. And when an intermediate rock melts, it will generate a magma that is felsic composition. right? Now, if you think about it, the observation is that many of the magmas that erupt on the surface of the earth as lavas are mafic in composition. And this then requires that they have been generated by partial melting of an ultramafic parent rock. That's the only way you can make a mafic magma, by partial melting. So the observation that the magmas are mafic requires that the parent rock, the rock in the mantle, be ultramafic. And we know it can't be the rock in the crust, right? Because we know the composition of the crust isn't ultramafic. We know the composition of the crust is closer to intermediate in composition, right? So we know the crust is intermediate in composition. So if it were the crust melting, or partially melting, I should say, it would be generating magmas that are felsic in composition. And that, in fact, actually happens. That is one of the major ways to create felsic magma. But the observation, once again, is that there are many mafic magmas, and these can only come from partial melting of an ultramafic rock, which can't be in the crust. So therefore, it has to be in the mantle. And that's one of the arguments, that the mantle has to have an ultramafic composition.